This is what a quadratic equation looks like. Its format is of the nature x squared plus 2x plus some constant number equals 0. It's called a quadratic equation because the highest power of x is 2, hence quadratic. For example, if the index for the 2's at the moment were 3, it would be not a quadratic equation, it would be a cubic equation, and so on. If it were x cubed and x to the fourth, it would be a quarter equation, and so on. So the quadratic equation will always have an x squared term in it. Now, the general format of a quadratic equation is ax squared plus bx plus c equals 0, where a must be unequal to 0. So, for example, the coefficient b for the x term could be 0, and the constant c could be 0. Even the simplest quadratic equation you could have as a x squared. But of course, the coefficient a could be a 1, in which case the most simple quadratic equation could just be x squared To solve a quadratic equation means finding the roots of the equation. And every quadratic equation will have two roots. Because if you consider something like x squared equals 9, then x would be equal to the square root of 9. Now, the square root of 9, as we know, is 3. But we also know that the square root of 9 can be minus 3. Because when I multiply minus 3 by minus 3, I also get 9. That's why every quadratic equation will have two roots. Now, very often, at first glance, some expression may not seem like a quadratic equation. For example, if we have something like x squared equals 4x minus 6. Now, looking at the general format, we see it should look like something ax squared plus bx plus c equals 0. So this equation we have here, there's no sign of a 0 in it. However, if we gather all the terms to the left-hand side, like so, we get x squared minus 4x plus 6 equals 0. In other words, as you well know from the previous example, I've just subtracted 4x minus 6 from each side. So now we've got the expression in the correct quadratic format.